through the city backsides. I see the stars come out of the sky.
Today we'll finish off 4.3, which is on analyzing logarithmic functions. And a reminder from last time that a logarithmic function is the inverse of an exponential function. Here is what we're interested today, and there's one letter we didn't look at last class. It's the A out front here. So last time we just introduced y equals the base b logarithm of x. We didn't have the a value up front. There was actually an a value, right? What was the a value if we didn't write anything? It was just 1. So we're going to look at two things here today. We're going to look at what's the impact on the graph of a logarithmic function if you change the b to a different number and if you change the a to a different number. Now, there was some rules, some restrictions with this. Remember that x has to be greater than 0. Remember that b has to be greater than 0 as well, and remember that b cannot equal 1. So for the first part here, where we are going to look at changing b, we can't look at any b values that are negative, because you're not allowed to have negative. You can't have b equals 0. You can't have b equal 1. So the two really interesting areas probably are when b is greater than 1 and when b is between 0 and 1. So in other words, when 0 is less than b, which is less than 1. These are the two things we're interested in. So we're going to start with something I think we graphed last day, the base 2 logarithm of x. So in order to graph this, I'll set up my xy table, but it's kind of hard to figure out some points when it's in this form. But do you remember that y equals the base 2 logarithm of x? There's another way you can write that. You could write this in the exponential form. So in exponential form, what's the base? The base is this number here, 2. What's the exponent? The exponent's always by itself in a logarithm, so it's y, and that's equal to x. So we could use this in order to get some points to graph here. So is it going to be easier to pick points for x or points for y? Definitely points for y. So let's do our classic 3, 2, 1, 0, and we'll go down to -1. So if you put if you put 3 in there, you get 2 cubed, which is 8. If you put 2 in there, 2 squared is 4. Put 1 in there, 2 to the first power is 2, 2 to the 0 power is 1, and 2 to the -1 is 1/2. And this should be good to graph these. So 8, 3 is 1 point, and 4, 2 is another point, 2, 1 is a point, 1, 0 is a point, and 1/2, -1. And hopefully that's enough. We could put more points, but hopefully that's enough, and especially if you remember what it looked like from last day, to see that this is an increasing function. It goes up like this, and then it comes down here, and it's getting closer and closer and closer to the y-axis, but it never makes it. The y-axis is an asymptote. So we'll highlight that one, and that is y equals the base 2 logarithm of x. Great, so now what we're going to do is we are going to try the base 4 logarithm of x. We're going to see what happens when we make that b value a little bit bigger. So again, we'll set up our table. Again, we'll pick in the y value 3, 2, 1, 0, -1, and again, we'll actually use the exponential form of this. So that would be 4, the base is 4, the exponent is y, and that equals x. So 4 to the y equals x. Put a 3 in there, 4 cubed is 64. Well, that's too big for the graph. Put a 2 in there, 4 squared is 16. 1 in there, you get 4. A 0 in there, you get 1. A -1 in there, you get a quarter. So the first point we can graph, I guess, is 4, 1. So that's right here. Then 1, 0 again. And then we have 1/4, -1. So we have very similar looking here, and you get the idea there. Okay, so that's as it's getting bigger. As it gets bigger, you can see this is coming down, down, down like that. What about if it gets smaller? What if, so we've looked at when it's greater than 1. What if the b value is between 0 and 1? First of all, I'll highlight that, and this one too. So this one in exponential form is 1/2, that's the base, raised to the y exponent equals x. So x and y, And I think we have to put a few more points in here. You'll see in a second. 3, 2, 1, 0, negative 1, negative 2, negative 3. So if you put 3 in there, 1/2 cubed, a half times another half is an eighth. 1/2 squared is a quarter. 1/2 to the first power is a half. 1/2 to the 0 power is 1. 1/2 to the negative 1. So that's a flipping negative to turn it into 2. 1/2 to the negative 2. That's a flipping negative, and then square it, you get 4. And 1/2 to the negative 3, flip it to get 2, and then cube it, you get 8. Okay, so 1/8 and then 3, so it's somewhere around here. And then 1/4 and 2, and a half and 1, and then 1 and 0, 2 and negative 1, 4 and negative 2, and 8 and negative 3. So obviously you can see that if your b value is between 0 and 1, you actually end up with a descending function. Same asymptote, which is the y-intercept. And interestingly, that they all go through the same point here. They all go through the point 1, 0. So maybe we should write that down. All these functions pass through the point 1, 0. And they also pass through another point in common. It doesn't look like it, but there's another point that's really important. And it's the point when you put 1 into the y. So this point 2, 1, 4, 1, 1/2, 1. What do you notice? This 2 here is that number right there. This 4 there number is that right there, and this half is that right there. In other words, it's always going to pass through the point b, because that's what that is right there. This is the b value. It's always going to pass through b, comma 1. So those are 2 points it's always going to go through regardless of what the b value is, right? Regardless of what the base is. So that's very important to know. Now there's 2 special logarithms we're just going to quickly mention. One is called common logarithms, and just like the name suggests, they are the most common ones. They have a base of 10. So what that would look like, obviously, is y equals the base 10 logarithm of x, or because it's so common, if you just put no base at all, then it's taken to mean that it's a base 10 logarithm. It's kind of like, you know, when you write this sign here, if you put no number right here, what does that mean? It means there's actually a little 2 here, but you don't have to write it, right? You can just leave it without a number at all, and we know that there's a 2. Well, same here. If you have no base here at all, then we take it to mean it's a base 10. Okay, if you're going to use your calculator ever for to do a common logarithm, you just use the log button on your calculator. It says log. There's also natural logarithms. Natural logarithms don't have a base of 10, they have a base of e. Do you remember e? We talked about it before. It's an irrational number, and it's approximately equal to 2.718. Remember, it actually goes on and on and on forever, but that's approximate. You can write that as y equals the base e logarithm of x, or you can write it like this: y equals ln x. This means the natural logarithm of x, and those are the same as each other. And if you're using your calculator, you would use the ln button, the natural logarithm button on your calculator. And as I talked about before, e is actually a really important number when you're talking about finance or natural systems in biology, engineering, all sorts of things. Okay, but we won't talk too much more about that today. Let's move on. Now what we're going to look at is what happens if we change the a value. So we're going to keep the b value the same this time. You can see we have b value 2, b value 2, b value 2, b value 2, but we want to know what happens when we change the a value. So there's actually a bunch of different cases we want to look at. We want to look at when the a value is positive, and also when the a value is negative. Plus you want to look at when the a value is between 0 and 1, and when the a value is more than 1, and even when the a value is 1. So there's a lot to look at here. This first one that I have up at the top here, this is actually just the same thing we've already graphed on the other side. It's y equals 1 base 2 logarithm of x. You don't need to put the 1 there too. So it's actually just the same as this first one right here, the purple one. So I'll very quickly draw that one again. And remember what we said on the other side, it always goes to the point 1, 0, and it always goes to the point b1. In this case, that'd be 2, 1. And on the other side, we also saw it went through 4, 2, and 8, 3, and 1/2 -1 and 1/4 -2. So we're ready to go here. Again, I'm doing this one very quickly because we actually did this on the other side. I'll take a little more time with the other ones. Okay, so let's move on. Now we're going to change that 1 to a 2. We're changing the a value from a 1 to a 2. And in order to do this, I'm actually going to use online graphing calculator. So 2 times the base 2 logarithm of x. If I go to Desmos, which is a really awesome online graphing calculator, so what's on my Desmos graphing calculator right now is the graph that we just did. So that's this yellow one right here. You can see that it's y equals 1 base b logarithm of x, but I've set the b to be 2, so this is the base 2 logarithm of x. I'm going to keep that 2 there the whole time when we do this. I'm just going to change that number up front. So for now it's 1, and that's the graph that I just drew for you, the yellow one. And now what we want to look at is what happens when I change this to 2. So let's change that to 2. And you can see it seemed to jump up there. So let's take a look at some of the points that we can see and graph those points. So one point I see is it goes to the point 1, 0. Interesting. Another point it goes through is 2, 2. Believe me, there it is, 2, 2. So 1, 0 and 2, 2. Let's go back and put those points in right now. So 1, 0 and 2, 2. Okay, let's go get another couple points here. It seems to go through the point 4, 4. Definitely goes through 4, 4. And also, how about this point right here? 8, 6. Again, I have to move my mouse. There it is, 8, 6. So 4, 4 and 8, 6. Let's do those points. Here's 4, 4 and here's 8, 6. So we can see this part of the graph up here. I'll finish the rest of the graph in just a second. Here's what I want you to notice. You see how this, the y value of this point here was at 1, right? Right here it's 1. And now that point is at 2. This point here was at 2 and now it's at 4. This point here was at 3 and now it's at 6. What's happening to all the y values of these points? They're being multiplied by 2, right? There's a 2 up front. That's what that 2 does. It multiplies them all by 2. Well, why did this point stay the same? Because it was at 0 and 2 times 0 is still 0. So this is why you'd expect it to be the same. Now this point here was at -1. Where would we expect to go to? -2. This point here is at -2. We'd expect it to go all the way down to -4. Anyway, it gets closer and closer and closer to the asymptote, but it's going to look something like this. So we have an increasing function, but it's increasing faster when we have the 2 there. Let's actually go down to the 1/2 next. So we'll do this one next. So let's go back to my graph, or my graphing calculator, and put 0.5, right? 1/2, 0.5, same thing. So I'll put that in. And I get this. So again, let's get a few points. Well, there's the 1, 0 point again. And this time we have 4, 1. And we also have 8, 1.5. 4, 1, and 8, 1.5. 4, 1, 8, 1.5. And it went through the 1, 0 point again as well. Okay, what's happening here this time? Well, take a look at the yellow one. When the a value was 1, the y value at this point was 2, and now it's down at 1. It's half as much. Here, the y value was 3, and now it's 1.5. Half as much. Oh, so the half here just this time makes it go up slower. It's going up half as fast. So again, this point here was at -1. Now it's going to go to -0.5. This point here was at -2. Now it's going to be at -1. Hey, why did this point not change? Because half of 0 is 0. So you get something that kind of like that. Okay. All right. Very nice. Let's now go to this bottom one down here. So the only thing I need to change is to make the a value negative. It's going to be -1/2. Let's see what happens. Ready? Watch carefully. Here comes my negative. Boom. See what happened? Let's take a look at some of the points. Still the 1, 0. Very nice. I see 4, -1. And I see 8 and -1.5. So 4, -1 and 8, -1.5. 4, -1, 8, -1.5. And again, it went through this point. What's happening this time? What's the easiest way to get this? The easiest way to get this is to look at the last one we just did, this green one, and you see what putting a negative in front of it did? It just did the flipping it over, or reflecting it over the x-axis. So this point here was 1 above the x-axis, now it's 1 below. This point here was 1.5 above the x-axis, now it's 1.5 below. This one was on the x-axis, it's still on the x-axis. This one here is, I guess, down a half, so it goes up a half. This one here is down a half from the x-axis, now it's up a half from the x-axis. It's basically exactly the same as the green line, except it is reflected over the x-axis. And with that in mind, we should be able to graph this last one very quickly as well. Horrible color, but which of the graphs you've already drawn is going to help us graph this one? Well, since we're graphing -2, it would probably be very helpful to look at the 2, because all we're going to do is take that one, this blue one here, and we're going to reflect it over the x-axis. This point here was 2 above, it's now going to be 2 below. This point here was 4 above, it's now going to be 4 below. This point up here was 6 above, it's now going to be 6 below. This point was on the x-axis, it'll stay there. This point was 1 below, it's going 1 above. This point was 2 below, it's going 2 above, etc., etc. I hope you can even see this graph. Yeah, it's okay, I guess. It goes something like this, and it should look like a perfect reflection of the blue line. If you don't believe me, you think I'm just making stuff up here, we can certainly go over here and put -2 in there, and you should see it looking exactly what we just drew. And I don't know if you're convinced or not, but that's it right there. Okay, very nice. Last thing we want to do is we want to generalize some of the things that stay the same and change of all the graphs we've drawn. So these 5 graphs we've done here and these 3 graphs we've done here, what's the domain of all those graphs? They're actually all the same. For all those graphs, the lowest x value is 0, but not quite 0, it never gets there. And then it goes forever off to the right. So in other words, all the x values are greater than 0, but not equal to 0. The other way you could write it is from 0, but not including 0, all the way up to infinity. What's the range of all of them? Well, they all go up and up and up and up, and they all go down and down and down and down. In other words, the range is y is an element of the set of real numbers. All real numbers. You could also write that as -infinity to infinity. What's the x-intercept? Well, interesting enough, they all go through the same point. They all go through the point 1, 0. Those all go through 1, 0. These all go through 1, 0. Every single one of these goes through 1, 0. That's the x-intercept. How about the y-intercept? There is no y-intercept. The y-axis is an asymptote. So it's never going to touch it. It's never going to cross it. There's no y-intercept. The asymptote, I just said that. The asymptote is the y-axis. What is the equation of the y-axis? Well, all the points on the y-axis have the same x value. What's the x value of every point on the y-axis? The x value is 0. And the end behavior. Remember end behavior? End behavior is where it starts and ends. Where do every single one of these graphs we've drawn start and end? They all start in quadrant 1 and go to 4, or start in 4 and go to 1. Some of them are increasing, and some of them are decreasing. But they all go from 1 to 4, or 4 to 1 if you want. And that's it. Okay? Those are the that's true for all of these graphs that we've done today.